This is a video covering the test-taking strategies or important ideas for the math section of the SAT and all the key concepts. So the biggest thing is to make sure you do not spend too much time on problems you have no idea how to do and play educated guessing. So for a moment, I'm going to go to the sections of the SAT here. So here are the sections. Reading is 65 minutes and 52 questions. The writing and language, 35 minutes and 44 questions. The math, no calculator, 25 minutes and 20 questions. That is the tough part in math, is the no calculator. And then the math with calculator, 55 minutes and 38 questions. To be college ready, for what that is worth these days, you're going to have to get, in my estimation, 34 out of 52, 29 out of 44 on each successive test. So reading, 34 out of 52, the writing and language, 29 out of 44, the math, no calculator, 13 out of 20, and the math with calculator, 24 out of 38. And the math is combined. So if you got, so it looks like 37 when you combine the top. So if, there's that little annoying advertisement that I can't get rid of. So if you combine the top two numbers, you just have to get a combination of 37 right. So if you got 0 out of 20 and 37 out of 38, you have it. So if you're not so good without a calculator, you can be good with a calculator and still get college ready. Okay, so back to this list here. Make sure you read through all the questions. There are easy ones at the end. This is so important. The SAT is really written to get you to stumble and fall. So here's a question towards the end of the no calculator. So it's the greatest possible integer that satisfies that equation. This is a very simple question. 14. You can literally guess and check in. This is problem 18 out of a 20 problem list in the no calculator section. Play the numbers game. This is a huge strategy by turning all variables, variable expressions into a number by letting variables equal a value, and find the answer by matching up values. When you see the answer choices as variable expressions, this is the sign you can use the method. This is so very important. Let's take a look at a problem. So you see here on this particular test, problem 13, and the blue, just so we got a lot going on here, the blue is how you would do it by hand. So there's always those of you that would want to go by hand. The highlighted one is one that's, the problem is it's no good because you get, when you pick your value, you get 6 twice here in your list. You can hear my coffee maker going off in the background there. And that's no good. You have to have all different values for an outcome there. So by letting x equal 2, so I turned everything into a number by letting x be 2. So I just went down the list here, and 2 times 2 minus 2 is 2. 2 times 2 plus 2 is 6. So I evaluated everything. Then I went up to the main expression, and I let x be 2, and I came up with 6. And again, the problem is these two here are both 6, so we can't tell. Again, this is a test strategy, turning everything into a number. Then I let x be 3. And I went down the list here and plugged in 3 and evaluated all of these and came up with these, and then went up above here and put 3 in and crunched out all of these values. So this is a no calculator part, so you have to do this without a calculator. So 8 is what you get for A up here when you let x be 3. So which one of these is 8? Or I'm sorry, which one of these here is 8 when you let x be 3? And it's the second one, so B is the answer. So here's an extremely complicated question where you can turn everything into a number, and just by playing the numbers game, you can find out which one it is. And I even put a mistake, not a mistake, but one that didn't work, where you get the same answer twice. That could happen. And then certainly there's always the way by hand. But this is a strategy that I find works more often than not. And the key is, how did I know to use this? Because my answer choices are variable expressions. That's the giveaway that this method can be used. Number 4, substitute when possible. This is the guess and check way. And number 5, multiply to eliminate denominators. This is huge, and you're going to find that as you look through these videos, this is a huge strategy on some of these. So here's a test problem. If 1/4 x plus 1/5 y is 6, what is the value of 5x plus 4y? Well, I know this in how I teach mathematics is that when I am dealing with equations, I want to try through multiplication to eliminate a denominator. So right away, I see the 4 and the 5. I know I can multiply left to right by 20. So 20 is a number that both 4 and 5 go into. You could multiply by 40 if you wanted to, or 60, whatever 4 and 5 go into. And it just so happens by doing this that the answer falls into my lap. So by multiplying left to right by 20, again, the smallest number that 4 and 5 go into, I come up with 5x plus 4y equals 120. And so that's what the question is asking. What does 5x plus 4y equal? I got lucky doing that, but you need to think in terms of eliminating fractions all the time. And there's just tons of, there's some other particular problem around here. Of course, I can't find it when I want it. Tons of situations where that comes about. Probably was in a different test anyway. You want to, for sure, always have that strategy in the back of your mind. And then these key concepts here, read through them. It's really kind of takes you down the list of things we are going to cover in this course, especially percent increase and percent decrease and straight percent. The reason I have this in big, bolded writing is it is the most important concept, the most frequently covered concept on the SAT, the ACT, the word keys, and it's something that we will hit hard in this class. So these are some strategies, and I will be emphasizing them throughout the course.